Hello, this is Joseph. Welcome again. Another tutorial. This is for a Toyota, actually, RAV4, 2003. And I want to thank the comments that I've been getting. And I welcome all comments, and especially one from Sam. And thank you for your comments, and I will take everything into consideration. This is my first year doing this, and sometimes I have to try to find the groove that's correct. If you do schematic interpretation, if you do it too technical, some people will not understand. As they told me, I get too technical and they get lost. And if you do it too simple, then people will say, well, you weren't technical enough. So I'll try to balance it out and try to give people a better interpretation. So thank you for all the comments. As you see over here, we're dealing now with a defogger circuit over here. As I said, where to start in a schematic. First of all, before we troubleshoot, we have to analyze and understand what's going on. Now, you always have a power source. In this case, from power source system. It could be from the fuse distribution box. It could be from the battery itself. Whatever it is, we know we're getting 12 volts. This is without the engine running. With the engine running, it's 13.6 to 14 in that range. However, when you start over here, you focus on main components. What are main components? A relay is a main component. Okay? Now, let's say the defogger doesn't work at all. First thing is first. Let's see how it works. We have a switch over here, which is important. That's a main component. We have a little filament, or when you press the button, when you activate this button on your dashboard or the climate control, actually, this little light goes on. And the filament, the bulb, goes on. And it tells us that this switch has been activated. Other thing is, obviously, the defoggers itself, the heating elements themselves, of which you have many going across the window like this. These are heating elements. Once current goes through it, it heats up. So, keeping this in mind, as you see in the schematic, we try to figure out how current flows, not voltage, but current. If you look at it, and I was asked one thing by when you teach these things, certain make and models. When it comes to the computer, which is the PCM or the ECM, in certain make and models, say GM, they'll refer it to powertrain control module. Let's say in Toyota, it'll be ECU, depending on the year on the model. Electronic control unit. It might be called ECM. Might be called something else, depending on the make and the model. But the purpose doesn't change. The computer, the main computer, the PCM, the ECM, those are the microprocessors, the brain of the car. Now, keeping in mind, where do we start from? Well, first let's understand, we have a relay over here. I focus first on the relay. I look how it gets the B plus and how current flows through it. As you see over here, I put A, B, and C. B plus, this is the primary circuit over here. This has to conduct first in order to get a magnetic field to energize this contact to close the armature. So when current flows over here, this is the fuse, right? Current flows from the battery or through the other fuses, or like we said, through here, this side of, I believe it's F8, comes out the other side. Current flows through the other side. Why does current flow through the other side? Because this fuse is good. So now I get 12 volts here. How much should I get over here? I should get 12 volts. Why? Because this is a piece of wire. And a piece of wire does not have that much resistance, so we do not lose much voltage through it. Probably less than an ohm, maybe 0.2, 0.3 ohms. So if it's 12 volts here, 12 volts here, if this fuse is intact. As I said, when current flows, we have two paths. Which path do we take? And this is why I always teach current flow, not voltage. Current has a path to go here. But when does current go here? Current can only go here when this switch is closed, when you activate or you depress the switch in your climate control box or dashboard. That allows current to flow here. Now there's another path, as you see by the arrows. This current will flow through here, through this coil, energizing the coil, back to this. And it's a little weird why they have this. They could have just had this, like this, go like this, and like this. Why they have this branch is a little odd to me. It really doesn't make sense to me. What's the purpose of this? This is giving a ground, basically, to this. We need a ground to complete the path. When you have relays, you always look at one side is B+, the other side is a ground. The computer can give you a ground. Or, in this case, it's not the computer. It's actually a switch and a bulb. Therefore, current flows here. Once this is closed, right? Then current goes here, 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 here. And now we have our ground. And again, it seems like this is extra. This over here. We could have had the same circuit go like this, like this. We have a ground. Once this is closed, boom, like this. So basically, when we close this switch, we're making this filament light up. That's our first indication of what? That the switch is good and that this fuse is good. Now keep that in mind. Again, this is lighting. Okay? That means the fuse must be good. Current can flow. And this is why I teach current. Current can flow. Current can flow through the relay. That means the relay, there's no open between these points. And current flows through this. That means the switch is good. It's not kept open. You can close the switch. So that's number one indication of this component being good, this component being good, this component being good. What about the other circuit? Well, notice another thing also. This is about 10 amps. Not too much current. Which has the most current? Right here. The one that has all these heating elements. Look at this. 30 amps. Compared to 10 amps. That's 3 times more than this one. Why? Because there's a whole lot of heating elements in that window, in the back window, which take a lot of current. Once this is energized, what happens? As you see over here, I put B+ going to A. B+ has to go to A. Then you have B, then you have C. Now current can flow through one side of this fuse, come out the other side, right? This is closed now because of this magnetic field that's energized. This is closed, it's pulled in. Current can flow now through the heating elements, right to this. So therefore, what do we need to happen? First thing is we need a ground for this. Where do we get the ground? This switch. If this switch remains open, guess what? This is not activated. If this is not activated, current does not flow here. That means current cannot flow here. Why? Because this is kept open. If current does not flow here, no current is flowing through the heating element. No heat to defrost or defrost the windows in the back. So that's why I started this video by saying, make sure you have this working. By this working in this case tells me I have a ground. It tells me that at least one side of this relay is working when this is lit. Very important to pay attention sometimes to LEDs or bulbs. When you press them, you know that fuse in that circuit is working correctly, is intact. I have 12 volts here, 12 volts here, 12 volts here. Why do I have 12 volts? Because I didn't lose any voltage drop. How much do I have here? 12 volts. Why? This is just wires. I didn't lose anything. Right? Now we come over here. Right? We come over here. Here, here. And maybe we'll measure a little voltage through this little bulb over here on this side. So therefore, again, the defogger doesn't work. What's the first thing that I do? I pay attention if this is lit. This is lit, the switch is good, the fuse is good. At least one side of the relay is good. If I want to, I can go to, and I always choose a point to go right here, to go to C and see if I get 12 volts. If I get 12 volts over here, what does that tell me when I'm troubleshooting? That tells me automatic, one-shot troubleshooting. I refer to it. If I get 12 volts over here, that means all of this is good. All of this is good. The switch is good. The bulb is good. If this would be open and this would be closed, I still wouldn't have a path to go to ground. That tells me that the bulb is good. The bulb is not burned out. This is good. This is good. And that's why I get 12 volts over here. One shot. But what's the problem? How are you going to put your probe in the relay testing it in circuit? Unless you have a relay inserter, or you have those relay boxes that you can put in. So this is a hard place to get to, right? But you could go to the rear window defogger, but that's also a hard place to go to. That's why I pay attention to this. Sometimes it's hard to get access to these type of places. Now, somebody was asking me a question about fuses. Main fuses and other fuses. There was a comment. If you have one fuse over here, F1, like I believe I had in that diagram, and I have F2 and I have F3. If this one blows, this is 12 volts, this is 0 volts. That means now this is 0 volts, this is 0 volts. That means there is no voltage here, and the current cannot flow. If current cannot flow, I don't have voltage. So therefore, 12 volts over here, 0 volts over here tells me this is open. Why is it open? Because there's no connection. At this point, it's connected to the battery, but this point is not connected to the battery, and now it's an open circuit. So therefore, after this point, 0 volts, 0 volts, 0 volts, 0 volts. I hope that answered that question. The other thing is the basics of the fuse. How do I know if it's bad? How do I know if it's good? We said over here, if this is 12 volts over here, and I have 12 volts over here, it means it's good. That means I'm still connected to B+. If I have 12 volts over here, and I have 0, that means that the fuse is bad. I'm not connected to the B+. If I have 0 here, I have 0 here. What does that mean? That means I have no connection to B+ at all. What's the question? Can this fuse be bad? We don't know. Why don't we know? Because we don't have 12 volts to it. So we don't have 12 volts over here. We have to go backtrack and say, where's the 12 volts? Where did we lose it? But at the same time, I doubted that this fuse would be bad. First thing is first, work backwards and say, where did I lose the 12 volts? Okay? In other words, let's say I have 12 volts here, 12 volts here, this is good. Let's say I have 0 volts here. And I say, uh-oh, a blown fuse, right? I call them over here and I say, the 0 volts. Uh-oh. Doesn't mean the fuse is bad. That means I'm not connected, and I have to backtrack and go and see where I lost the 12 volts in the power source. Another question or comment is given about the meter that I use, the amp meter. That one I bought years ago actually in an auto parts shop. I have not been able to find it online, something similar to that. Maybe there is something similar to that, but that's why I didn't put any link where that is available. I bought it years ago, actually. It cost like maybe $60, $70 in the auto parts shop, the one that you see in the videos. About the batteries, a comment was said, what I said was you can increase the ratings. Cold crank amps, which is 0 degrees, and you have the other one at the other one, which is cold cranking amp, which is 0 degrees. The other one, cranking amps, is at 32 degrees. What I said was you can increase the battery to change to a different battery to a more higher ampage. Not that that battery can give more current. Whatever the current rating is, that's what it can give out. What I meant was, in the wintertime when it's cold, instead of 500 cold cranking amps, you can use 800 cold cranking amps, and you'll see the difference right away, how you start quicker. You won't have many problems. Anyway, I hope this helped. And again, the defogger doesn't work. What do I do first? Pay attention to this. This is a good sign, right? Again, if this works, we know all of this works. Then we'll work through here. Thanks for watching, and like I said, I have another channel, Joe Electronic Schematics for Auto, and that's where I teach the basics of electronics, the fundamentals of electronics, and hopefully that will let you understand and interpret schematics. Thanks for watching, and thanks for your comments.